Hey everybody, and welcome back. I've been taking a break from the shop and working on something here in the computer lab. I built a CAM program specifically for plasma cutters. I wasn't really happy with the open source options that were out there already. I mean, why not build a complicated computer program to go along with your complicated metal cutting robot, right? I mean, it's only hours and hours and hours and hours of your life, right? Today we're going to use that CAM program, which I have christened MetalHeadCAM, to make its first cuts. So let's get to it. Let's jump right into it. This is what you'll see when you open up MetalHeadCAM. This is a temporary URL. I will be posting the link and keeping it up to date in the comments. So be sure to check there. Let's open up our DXF. Doesn't matter how you produce this. I produced it in Onshape, but as long as it's a valid DXF file, you're good to go. After we open it, you'll see that we're kicked into the edit stage. Right now, this doesn't do much. My plan is to turn this into something like Inkscape, to turn it into a proper vector editor, but for right now, it's good for scaling parts, deleting them and rotating them. Let's jump now to the prepare stage. This is where the program's going to start making sense out of all these individual shapes. For closed shapes, we're going to generate parts from them, and all connected shapes are going to end up being chains. This will become relevant in the next stage when we program these into G-code. On the prepare stage, normally all you really need to do is just click apply, and it takes care of everything for you. You'll see here that it has correctly detected that we have one part with 4 holes. And for right now, that's all we really needed. So let's then jump to the program stage. Let's click on our part and add an operation. You'll see by default, it has figured out that it needs to do what we call part curve compensation. So for the outer part of the shell, it outsets to adjust for the kerf width. And for the holes in the part, it insets. So now let's jump to simulate, click play, and it's going to simulate our cuts. So you can see there that the red cross is the tool head, and it's basically tracing out exactly what the tool would do. So now that the simulation looks good, we can go ahead and export our G-code. It's generated for us automatically anytime we change something, so all we really have to do here is click download. Then we just download it to the same directory, and now we can pull this off and go to the plasma cutter. All right, so here we are back at the plasma cutter. All we got to do is open up our G-code file. There it is. So select it, and boom, there it is. All the G-code we generated. Torch is on, ohmic probe is on. Seems like we're good to go. Let's give it a shot. And there it is, first cut program with MetalHeadCAM. Now for a little healthy self-criticism. Let's see what we got here. So my cut speed is pretty clearly off. I think I should have reviewed the cut chart before doing this, but that's not really related to the cam itself. Pretty clearly a problem with the holes here. I checked these out already, and the underspeed is not working for some reason. These are supposed to be cut with a 60% underspeed, which would have made the sides quite a bit straighter. That did not work, and I got to go back and review how I'm generating the program to figure out what the issue is. The other problem you'll see here is that I have currently not implemented leads in the program, so the arc is starting right on the edge, which is putting this little divot here, this little divot here in, but that feature's coming, so no major concern there. All in all, not bad for a first go.